This is SpaceTime, Series 28, Episode 46. Coming up on SpaceTime, how black holes generate their powerful plasma jets. NASA's Mars Perseverance Rover observes a string of Martian twistors. And getting a greater understanding of how the Earth's tectonic plates move. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has unraveled some of the mysteries behind the forces that generate those powerful superluminal jets that shoot out of the accretion disks of black holes. Black holes are fundamental to the structure of galaxies, and they're critical to science's understanding of gravity, space and time. In their simplest terms, black holes are points of infinite density with zero volume, places where gravity becomes so strong that nothing, not even light, can escape. A stellar mass black hole is a type of black hole that forms from the gravitational collapse of a massive star at the end of its life. These black holes typically have masses ranging from 3 to 20 times that of the Sun. Occasionally, they'll generate powerful beams of plasma or ionized gas that shoot out at nearly the speed of light. These are generated as material falls onto a black hole's accretion disk. It's then crushed and ripped apart at the subatomic level, in the process releasing huge amounts of energy and matter. Although discovered more than a century ago, the exact mechanism that explains how and why these jets occur has remained somewhat of a mystery. But now, a report in the publications of the Astronomical Society of Japan has found that this jet formation occurs when superheated gas material experiences a rapid shrinkage towards the black hole's event horizon. The event horizon is the point of no return for a black hole. Once material passes this point, it's destined to fall forever into the black hole's singularity. The study's lead author, Kazutaka Yamoka from Nagoya University, says understanding jet ejection in black holes is crucial because it sheds light on galaxy evolution, on energy distribution in the universe, and on the properties of black holes themselves. The jets influence star formation, they distribute energy across vast distances, and they serve as cosmic beacons, allowing astronomers to locate black holes in the first place. Additionally, they provide important insights into the fundamental physics of black holes. Materials such as dust and gas gets pulled towards black holes because of their strong gravitational pull. This material then rotates around the black hole, forming a thin accretion disk. Yamoka and colleagues studied a binary black hole system consisting of a stellar mass black hole and a Sun-like star orbiting each other. They observed 5 or 6 jets emerge from the black hole over a period of roughly 20 days, making it ideal for studying this phenomenon. By analysing X-ray and radio observation data from this event, they were able to track down how quickly X-ray emissions near the black hole were changing over time, and they were able to measure the total amount of energy being produced by the jets. The results showed that the jets occurred when the inner radius of the accretion disk suddenly decreases and reaches what's known as the innermost stable circular orbit, the closest that matter can orbit around a black hole without passing beyond the event horizon. The authors realized that initially the inner radius of the accretion disk was located further away from the black hole, but on occasions the inner radius of the disk would start to shrink rapidly, eventually reaching this innermost stable circular orbit, and that's when the jets erupted. The jets would then continue to erupt for a while. However, when the shrinking movement of the inner edge of the disk stops, the jet itself would suddenly cease. Now from this, they identified 2 key conditions needed for a stellar black hole to create a jet. Firstly, the inner edge of the gas disk surrounding the black hole needs to rapidly move closer to the black hole itself, and this movement needs to reach the innermost stable circular orbit. Now, scientists already knew that when a black hole jet erupts, X-rays become softer, that is, more low-energy X-rays compared to high-energy ones, and they show fewer rapid fluctuations in a short space of time. This study discovered that these X-ray changes happen because the inner edge of the disk is rapidly moving closer to the black hole, and it's this which is the actual trigger for jet formation. As this inner edge shrinks, it produces more soft X-rays with less variability compared to highly variable hard X-rays. And this explains why the X-ray patterns change right before the jets form. So the study's revealing that the jets are formed under changing dynamic conditions rather than stable static ones. Now, scientists can better predict the occurrence of plasma jets. They'll be able to study the mechanisms behind them in real time. Yamuka says the findings may provide a universal key to understanding this phenomenon. While these binary systems, where a black hole orbits a normal star, differ significantly from the supermassive black holes located at the centre of galaxies, it's thought similar physical mechanisms are operating across all black hole scales. He says, though challenging due to their slower time evolution and difficulty measuring their inner structures, applying these findings to supermassive black holes and the quasars they produce will be the next step. This is Space-Time. Still to come, NASA's Mars Perseverance Rover observes a string of twisters on the rim of Jezero Crater, and getting a greater understanding of how the Earth's tectonic plates move. All that and more still to come on Space-Time. NASA's Mars Perseverance rovers just observed a string of Martian twisters spinning on the rim of Jezero Crater, and the spectacular sight included one dust devil that was consuming another. The smaller dust devil's demise was captured during an imaging experiment conducted by Perseverance's science team aimed at better understanding the forces at play in the Martian atmosphere. These swirling, sometimes towering columns of air and dust are common on Mars. The observations were made by the Six-Wheeled Mobile Laboratory's navigation camera at a distance of 1 kilometre. The event at Witch Haven Hill involved a larger dust devil, some 65 metres wide, devouring a much smaller companion trailing behind it, which was only about 5 metres across. Perseverance scientist Mark Lemon from the Space Science Institute in Boulder, Colorado, says that it shows that convective vortices or dust devils can be rather fiendish. These mini-twisters wander the surface of Mars, picking up dust as they go, in the process lowering visibility in their immediate area. Now, if two dust devils happen upon each other, they can either obliterate one another or they can merge, with the larger, stronger one consuming the smaller, weaker one. Dust devils are formed by rising and rotating columns of warm air. Air near the planet's surface becomes heated by contact with the warmer ground and then rises through the denser, cooler air above. Now, as other air moves along the surface to take the place of the rising warmer air, it begins to rotate. And when the incoming air rises into the column, it picks up speed like a spinning ice skater, bringing their arms closer to their body. The air rushing in is also picking up dust in the process. Consequently, a dust devil is born. Dust devils play a significant role in Martian weather patterns, and so studying them is important because these phenomena indicate atmospheric conditions, such as prevailing wind directions and speed, and they're also responsible for about half of all the dust in the Martian atmosphere. Since landing in Jezero Crater back in 2021, Perseverance has imaged these whirlwinds on many occasions, including one on September the 27th, 2021, where a swarm of dust devils danced across the floor of Jezero Crater, allowing the rover to use its supercam microphone to record the first ever sounds of a Martian dust devil in action. NASA's Viking orbiters back in the 1970s were the first to actually photograph a Martian dust devil. And 2 decades later, NASA's Mars Pathfinder mission was the first to image one from the surface, and even detecting a dust devil passing directly over the lander. The twin rovers Spirit and Opportunity also managed to capture their own fair share of dusty whirlwinds. And Perseverance's sister rover Curiosity, which is exploring Mount Sharp in Gal Crater on the opposite side of Mars, also spots dust devils on a regular basis. But capturing a dust devil image with a spacecraft takes some luck. See, scientists can't predict when they'll appear, so Perseverance routinely monitors all directions looking for them. When scientists see them occurring more frequently at a specific time of day or approach from a specific wind direction, they'll use that information to focus their monitoring to try and catch additional whirlwinds. This report from NASA TV.
We often see dust devils in the desert, but this one happened on Mars. NASA's Perseverance Rover captured an incredible new video, and I'm going to tell you all about it. Perseverance was exploring the rim of Jezero Crater when it spotted these twisters, 210 feet wide. That's like the wingspan of a large airliner. But if you were standing there, not to worry. The Martian atmosphere is so thin that it would feel like a gust of wind, though you'd get pretty dirty. Scientists are fascinated by dust devils on Mars. By studying these, we better understand wind patterns and surface-atmosphere interactions. Dust devils also tell us how dust lifting affects the planet's atmosphere and climate over time. We've even observed this phenomenon from space. The Mars Reconnaissance Orbiter captured a dust devil that was estimated to be 12 miles high. That's about the length of Manhattan. We've also captured the tracks these dust devils leave behind. These can tell us about the directions dust devils traveled. Every time we spot a dust devil, it helps us refine our climate models of Mars.
And in that report from NASA TV, we heard from Perseverance Atmospheric Team Specialist Priya Patel. This is SpaceTime. Still to come, a greater understanding of how planet Earth's tectonic plates move, and later in the science report, a new study warns that less than 10 minutes on TikTok's all it takes to make women feel worse about their bodies. All that and more still to come on SpaceTime. A new study claims anomalies within a region of the Earth known as the mantle transition zone influence how the Earth's tectonic plates move over the planet's surface. The findings, reported in the journal Nature, suggest there can be extremely thick mantle transition zone regions, and these can only be explained by a large basaltic rock composition. The study suggests that in certain regions, entire oceanic slabs, now these are approximately 100 kilometres thick, end up possessing significant basaltic material. The study says compositional rock anomalies within oceanic plates caused by ancient tectonics influence the trajectory and speed of these plates as they plunge deep into the Earth's mantle. Eventually, they reach the mantle transition zone, which is located between 410 and 660 kilometres below the surface and is a critical region acting as a sort of gateway for materials entering the Earth's deeper mantle. Large distributions of basaltic rock compositions within the mantle transition zone can cause subducting plates, that's when one plate slides beneath another, to slow down or even stagnate within this zone, instead of continuing its descent directly into the lower mantle. Now, although basaltic reservoirs have previously been discovered within the mantle transition zone, their origins have remained unclear until now. The new findings, therefore, are providing a far greater understanding of plate subduction, which recycles surface materials and volatile elements deep into the Earth's interior. And that's important for sustaining long-term climate stability, atmospheric balance, and therefore the habitability of the Earth over billions of years. One of the study's authors, Catherine Reichart from the Woods Hole Oceanographic Institute, says this has been the first large-scale ocean bottom seismic experiment conducted on an Atlantic subduction zone. Reichart says she was surprised to find an unexpected and exceptionally thick mantle transition zone beneath the Antilles. At some 330 kilometres, it's one of the thickest transition zones observed. Although the Caribbean is well known for its sunshine and beaches, for geologists and planetary scientists, it now has a new claim to fame in the world of plate tectonics. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. New research by the University of Sydney has established a causal link between loneliness and early mortality among middle-aged women. The study, reported in the British Medical Journal, analysed data from an Australian longitudinal study on women's health. The population-based survey began back in 1996 with the aim of exploring the factors contributing to health and well-being of more than 57,000 women. A new study has shown that less than 10 minutes on social media, such as TikTok, may be enough to make women feel much worse about their bodies. The study, reported in the journal PLOS One, surveyed 273 women aged between 18 and 28, asking them how much they use TikTok. The authors then screened them for symptoms of disordered eating, body image, their attitudes towards beauty standards, and the risk of restricted diet and eating patterns with the aim of eliminating impure or unhealthy foods or behaviours. They then showed half the participants a roughly 8-minute compilation of disordered eating content from TikTok, including young women starving themselves or providing weight loss tips alongside juice cleansers and workout videos. The remaining subjects watch neutral content, things like nature and cooking and animal themes. Interestingly, both groups reported feeling worse about their body images after watching the videos, with the pro-anorexia content group reporting the biggest change and even a change in their beliefs about what constitutes beauty. The authors say that TikTok needs to become better at controlling pro-anorexia content on its platform. A Google DeepMind artificial intelligence program has successfully mined diamonds in the computer game Minecraft without using human training data. A report in the journal Nature claims the work had been considered a challenge for AI, as the task requires many different steps that only offer sparse rewards, and the long-term planning required to complete the task has always been challenging for artificial intelligence programs. The underlying general algorithm was also used on over 150 other tasks, including other games and robotic movements. Samsung's now commenced the rollout of its official UI 7 updates for Android cell phones. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.live.
The one UI 7 update is being released as we speak in the US and Europe, and it'll come to different countries over the course of next week and the next few weeks. In April, we'll see the S24 range, the Z Fold 6 and Flip 6, the Z Fold 5 and Flip 5, the tabs and the S23s. So that will give you all of the new One UI features, which includes the Now bar and the Now brief. The Now bar is a little bar on the lock screen that does show you music controls and other information. And the Now brief tells you about your day and what appointments you have coming up, what the weather is like, if there's going to be any diversions in your traffic that you need to know about. It's like a briefing, which doesn't exist on other devices, which is pretty cool. So you'll see more devices being updated in May and June, the rest of Samsung's range from the last 2-3 years, perhaps even longer, depending. And this is Android 15 underlying One UI 7, which means it's got the latest version of Android, all the various security patches. It's very important to do it. And there'll also be a feature that the Pixel 9 series is getting, which is the ability to hold your phone up and the phone can see what is being displayed by the camera. So the ad for the Pixel April drop shows somebody standing in front of a giant fish tank in an aquarium park of some sort, and as different fish are floating by, the person is saying, well, what fish is this? And they're being told by Gemini, oh, this is a Queensland grouper, for example, or it's, you know, whatever the fish is, and sort of you can have a conversation about it. Now, that's something that if you've got Gemini Advanced, you could already take advantage of, but you have to pay for that. This is coming for free for S25 users, and whether it comes for the other feature versions, I don't know, but certainly for all the Pixel 9 series, they're getting it as well, whether they pay for a Gemini Advanced or not. So it just brings forth this era where your phone is like this little robot in your pocket. It doesn't have arms and legs yet or a body to move around, but it does have eyes, which is the camera. And it can also look at what's on your screen and help you with various things as well. And we'll no doubt hear even more about that during Google's I/O conference sometime in May. And there's also news over the past little while that Samsung and Google are working together on the Borley robot that they announced a couple of years ago at CES. And it will work with Gemini AI. So that means it'll understand more than simply voice commands, but it can see and hear things around you. So that is an actual robot. It's a ball, so it's going to be very low on the ground, but be able to help you with various things. And it does hark to a day when we will have robots roaming around our houses, like we've seen in sci-fi movies for decades. Like Rosie the robot, yes. Our sci-fi dreams are definitely coming true by the end of the decade, and 2030 will look very different to 2025.
That's Alex Zaharov-Reutt from TechAdvice.live. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.